Great. Now you see my deck, right?
Yep, we can see.
Good. All right. So this is a 15-minute .NET developer overview of nopCommerce. So I am a developer, and I'm one of those optimistic developers. When I say 15 minutes, I probably mean 45. So hopefully I stick with 15. So I'm going to go through what is nopCommerce, and we're going to look at a little bit what the code base looks like. And actually, I picked a code sample that seems like is directly in line with the talk for tonight. So I'm kind of glad I chose that sample, unknowing the topic for what would be tonight. And yes, I also want to touch on a little bit on what I feel like the real value of open source is. So nopCommerce is probably the most popular .NET-based e-commerce solution that you can download today. That's truly free and open source, and has minimal requirements on how you actually use that software. The storefront out of the box looks pretty nice. It's responsive, and out of the box it just looks good and has a lot of the many common features you would expect. And on the administration side, when it comes to managing a lot of different aspects, not only products and sales, but there's ways to manage and change out different topics throughout the platform, as well as blogging. So it's a pretty full solution when it comes to the e-commerce space. So a little history on nopCommerce, been a little, was almost 12 years now that the first released. So a couple years later after the release, they had 5,000 active sites. And when they released version 2, that's when they switched over from web forms to ASP.NET MVC. And when they released their version 3.0, that's where they implement a lot of extra features like having multi-store aspects and multi-vendor support. And in 2017, that's when they released their 4.0 version. And that's when they switched over to ASP.NET Core. Or actually not switched, but started to prepare for ASP.NET Core. And from what I see on their website, as of September 2019, there are 60,000 active sites using nopCommerce worldwide. So the features out of the box, there's a lot of the common features that it brings. I wouldn't say any certain features stand out, but this is a pluggable architecture, and there's a market for customizing a lot more with plugins and themes. So the stack of this architecture is probably your typical Microsoft stack of an architecture. On the front end, it feels a little dated. Razor View engine is used, so Razor Pages is what's used most throughout the architecture on the front end with a little bit of jQuery. And there's a lot of discussions of where they're going next, whether it be Angular, React, or Vue, and Vue is brought up. It might even be Blazor, we'll see, since they like the Microsoft stack. And then more so on the back end, when it comes to the ORM, Entity Framework is in play here, and SQL Server. At least as of version 4.2, things have changed since the new version of 4.3, and I'm going to cover some of that. And it is good to kind of, when you're looking at these different technologies within this architecture, some that you might look over might be in the mid-tier where AutoFact and AutoMap are in play. So there's other libraries and aspects of this architecture that have a really good implementation to, that implement these other open source libraries that are really valuable. Even Fluent validation is pretty cool. So the one thing I like about nopCommerce the most is that it simply continues to evolve. Meaning, like, if we look back at, let's say, we'll just go back as far as version 3.9. And I started getting involved with the nopCommerce probably around version 3.5, 3.6. But version 3.9, when they moved to version 4.0, they were still compiling to the .NET framework. So 4.51 was the framework for 3.9, and 4.6.1 was the framework for 4.0. And they kind of prepared themselves for core when they moved to that version. And then when they moved from 4.0 to 4.1, that's when they started to compile to core. 2.1 was the original, or the first version of core they compiled to. And then in moving from version 4.1 to 4.2, that's when they started to support running on Linux and within Docker containers. Most recently, they released version 4.3. That was released about 3-4 months ago. And that's where they did some refactoring on data access, which and in some ways kind of took me by surprise. And they also targeted the 3.1 framework of .NET Core. In version 4.4, it's always good to check out what's going on GitHub. They're very open about what they're working towards. So like with version 4.3, when they said they're going to refactor data access and actually take out Entity Framework and start supporting MySQL, What you can see now is when they're working towards version 4.1, they're working towards supporting Postgres as well as MongoDB. All right, so let's kind of look at some aspects of the code. We'll kind of look at the architecture at a code level a little bit more, talk a little bit about plugins and themes. So the solution in nopCommerce, there's really three core libraries that make up, well, three libraries that make up nopCommerce. You have nopCore, which is where you have a lot of common code, even your domain model is in there. Nop.data, that's where a lot of your data access code resides. And then you have nopServices, where you'll find a lot of business logic with inside of there. You also have nopWeb, which is the storefront, and nop.admin used to be a separate project. It is now part of the same project, and that's why they had this library for the front end to be a reusable library for between nop.web and nopAdmin. But nopAdmin is now within the same project as nopWeb. Also within the solution, there's a good handful of unit tests across the different projects, mainly the library projects. And then out of the box, when you download nopCommerce, you get a good handful of sample plugins. nopCommerce on their GitHub site has a lot more plugins that you might want to download, use for free. And of course, there is a market where those different vendors selling plugins and even offering other free plugins. So, and looking at the architecture, it feels like a very fluid architecture, meaning like what you would expect out of architecture has separation of concerns done pretty well. So on the front end, nothing too crazy here. When a user makes a request, it goes to a controller, which instantiates a model, and that controller will return a view that has a reference to that model. So your typical MVC type of front end architecture. That controller has to get its information from somewhere, so it goes through a service. Again, this is not a multi-tier architecture like a microservice or anything like that, and it's all within the same solution. These are really just projects, but the way it's kind of broken out, it could be separated if need be. So the controller will work with something like a service or a factory, something that has a lot of business logic within inside of it. That service will then populate or work with a domain entity that'll then get filled within the model. So again, the separation of concerns, I think, is pretty well done within this architecture. That service works with a repository pattern to go get the data from the database. And that repository works with something called a domain mapper. Actually, within the version 4.3, they changed it to a builder, the naming of that. And that builder/mapper will then fill in the data or really kind of populate metadata around your entities. So like how the constraints around a certain property or how many characters a certain property can hold. That's the purpose of this domain mapper. Again, it's called a builder now. And then that domain entity gets filled into the model. So let's look at some code. Again, I think this code actually kind of aligns pretty well. Without knowing what's coming in the presentation, I feel like this is going to be a good lead into the presentation coming tonight. All right, so looking at things at a code level, here we are at the service layer. We have this get customer by ID, and that customer repository is actually, there's an interface of repository of type customer. So I've seen this pattern quite a bit when it comes to repository pattern, where you have repository of a type, of a certain type. And on that contract, that get by ID is one of the methods available. So if we take a closer look at iRepository, and we see that you got get by ID, if you kind of went through that some more, you'd see you'd have insert, update, delete, a lot of these different CRUD operations that make up, something you might want to do in the repository pattern. Now, iRepository in version 4.2 and earlier, you had this EF repository representing Entity Framework to where it inherited that interface, and then it implemented get by ID. And it's kind of funny is that this is actually a real comment in the code, or at least it was. And so it was really just doing an entities.find when it comes to a get by ID. Also off the repository, you have available this table property. And that table property is really almost like a pass-through to get to the IDB set of entities to access really what Entity Framework is doing under the covers. Now, this was kind of new to me when I first looked at nopCommerce. I've seen this pattern a little bit more since, but if we take a closer look at a particular method, let's say it's in the customer service, so it's in the business layer. Some people might say, oh, this should be in data access, but what I found interesting here is that you have this table property that in a way it's kind of making it available to where you can have this or this really link to objects type query that gets projected to entity framework because of how it implements the interface. So this is kind of a newer pattern for me when I first saw nopCommerce, but what this kind of led to nowadays, and this is where what I really like about nopCommerce is how it continues to evolve to where that coding pattern of allowing nopCommerce to kind of work with a linked to objects query and that gets projected to the ORM, which is entity framework. In 4.3, they decided to take out entity framework and implement link to DB, which was actually an ORM I was not familiar with when I saw this change. And what that allowed for them, what they've determined outside of maybe performance. Some people might argue entity framework is good enough on performance, but nonetheless, I guess they found that link to DB was better for performance, and that it was best to kind of utilize MySQL for that. So when it comes to supporting other data access possibilities. I just noticed I'm getting some red marks on my screen. Must be me and my clicker. Sorry about that. All right, so link to DB, it's an open source solution that's out there. A lot of people wanted the nopCommerce team to actually go to Dapper, a micro ORM, but I think they chose link to DB because they could kind of change out that link to objects query pattern. So yeah, it was a smart decision on their part in order to move forward, and they're getting a lot better performance now. So the marketplace, this is something to check out when it comes to different plugins and themes that are offered. There's some free stuff out there that you can check out as well. And when it comes to plugin development, there's a course out on OrmLite, and there's also some information out there on YouTube in general. But when it comes to extensibility, that's where you're utilizing themes on the front end, and plugins really make up how you want to encapsulate some business logic and even some data access. You might even have let's say you want to write a plugin that calculates tax, that you need to have some tax tables that your plugin needs to install. There's a pattern to implement a migration strategy for your plugin to create those one or more tables that you might need. Putting a theme in place is really just putting it into a certain folder, and you'll be able to select it from the administrator, and that theme is what it would use. All right, so what I found the real value of open source, I think nopCommerce is a great open source solution when it comes to just understanding full stack development. You could use nopCommerce as a secondary income, and I think the biggest takeaway is that it's a really good reference architecture for a .NET developer to have. So let's touch on some of these as I wrap this up. So one of the coding schools here in St. Louis is the Claim Academy, and they offer these two different full stack developer tracks, one of them being Java and one being .NET. And when it comes to being a full stack developer, it's almost like you're expected to be a generalist. Your front end, back end, database, and also automation with DevOps, and even on the mobile side. So this aspect of full stack development, or being a full stack developer, can be pretty intimidating. And how do you really prepare to be a full stack developer? So I kind of came up with 3 different things you really need to choose for as a software developer for your career. One of them is you need to choose a stack. One of those stacks simply might be Microsoft.NET, like this one. When it comes to a learning platform, I highly recommend you pick a learning platform, and almost like picking Netflix, I choose OrmLite. There's a good handful of other ones out there I'll touch on briefly. And then when it comes to an open source solution, nopCommerce is a really good one to check out in the .NET space. And I think it'll still be a while longer. So of those different stacks, I almost hate to say it, it's driven by a company usually. So you got the Microsoft.NET stack, you now have Oracle driving the Java stack, or Google, I can kind of throw that in. They're kind of coming up with their own stack, kind of spearheaded by Go in many ways. Then you got the community stack with JavaScript and everything else kind of thrown in. And yes, there's a lot of companies that have come up different things in the community stack, such as like with Google and Angular. But I recommend for developers to kind of pick a certain stack and kind of use that as their basis on learning. Sure wish I knew how to get rid of those red squiggly lines. Everybody's seeing it right now. I'll just keep moving on. All right, so when it comes to learning platforms, highly recommend picking one. I don't care what it is, just pick one. I recommend subscription because you're likely to use it more. Pluralsight, LinkedIn Learning is great. There's a lot of great stuff on YouTube, so I don't want to discount what's out there. But pick something and start watching it every week. And when it comes to all the different open source platforms, you have WordPress, which is still the most popular open source solution out there. Or even in e-commerce, when it comes to WooCommerce, you got Magento, Broadleaf in the Java space. But if you're a .NET developer like me, you probably want to check out one of these open source solutions that you might want to utilize as a architecture that you refer to. And of course, I've chosen nopCommerce for quite a few years now to keep studying. All right, so to wrap this up, the different opportunities in nopCommerce is that, there is a marketplace. You can sell different plugins and themes out there, which is great. You can become certified in nopCommerce and, focus on that job market if you really wanted to. You could apply the software. You could be a store owner. So you can set up a drop shipping site. You can have downloadable content. There's a lot of different aspects on how you could use this storefront, even if you don't have any physical products to sell. And the biggest one, I think, is really this is for you. As a software developer, I've been in a lot of interviews, and I've been on both sides of the table, to where, when it comes to job interviews, a lot of times you're talking about your current job or something like that, and you might be kind of giving away secrets or something like that of your current job or previous job that probably doesn't come across so great. Or you might have your own open source thing that you're working on, which I'd be cautious about talking so much about that as well, because the company might be thinking that you want to implement that open source solution on their platform. That may be a turnoff. There is this third option. You can have a reference architecture like nopCommerce or one of the other ones that you can talk about. So if someone asks you, what is dependency injection? What is I don't know, what is a plugin architecture? You have a reference architecture you could utilize here and even play with more and break things out and set it up into a microservice architecture. So I highly recommend, as a software developer, find yourself a reference architecture along with a learning platform and pick a stack that you want to get to know more and more when it comes to being a full stack developer. All right, so just recommend go download nopCommerce. It's free. Go check it out. The version 4.3 is touted as the fastest version ever. It now supports MySQL, compiles the .NET Core 3.1. I gave a talk at the nopCommerce Global Meetup, which is a new meetup that I created. So where we walk through a lot of these newer features of version 4.3. And yes, there's a online meetup with for the nopCommerce community. We meet the third Tuesday of every month. We just met this past Tuesday. Highly recommend checking that out. If you want more of a walkthrough of the nopCommerce solution, I went to Redmond about this time last year and did a walkthrough of the architecture. I was up in Chicago as well, and I gave a similar full version of this talk. Yes. So if any of this interests you, if you want a copy of the slides, or you want to present at the nopCommerce meetup, or even the St. Louis meetup. I forgot to mention I coordinate speakers and sponsors for the St. Louis meetup. We have been meeting virtually since we had to go virtual back in March. Yes, March we started to meet virtually. We've been having a good a good attendance for that. We have a really good meetup coming at the end of this month. So highly check that out, the St. Louis.NET meetup. So when it comes to the nopCommerce site, just go to nopCommerce.com. I will be launching a training site. So when it comes to learning how to create plugins and things like that. So Nop Academy is that training site. And there's a lot of other great resources out there. It's pretty well documented. I have nopdocs.com that'll take you right to their documentation. The nopCommerce YouTube channel, there's a lot to check out there as well. And again, the monthly meetup is the third Tuesday of every month. Third Tuesday of every month. And Nop Meetup will take you directly to the meetup page for that. All right, that's all I got. I wasn't expecting questions when it comes to, or if you do have any questions, feel free to ask, or we can wait till the end for that. But oh, the drawing. Did you want me to have people just email me for the drawing, or do you want to do something at the end?
I would leave it up to actually send out a spreadsheet where people can enter their names. Put the link in the chat. I think I see people have already entered their names.
Okay, great.
So if you want to, John, if you want to drop, we can do that Amazon gift card raffle right now. And
oh,
then,
really? No hurry. We can do it at the end with everything else too. I'm going to be sticking around.
Okay, great. All right. Thanks a lot, John.
All right, thank you.
With that, I'll hand it over to Mr. Jay Tower.
All right, sounds good. Thanks for sharing that, John. And thanks for having me at the ChicagoNet.net user group again. I think this, correct me if I'm wrong, but I think this is my third or fourth year in a row speaking at the user group. Does anybody have different information than that? That's what I'm remembering. So it's an honor to be back, although to do it from home this time, since we're all kind of living in a different world. I noticed, so I reached out to Mayank recently and said, well, I see you guys aren't meeting, so I assume we're off for August. And he reached back out to me and said, actually, we've been thinking about going virtual. Would you be willing to do that? And it's pretty exciting to be on your first virtual meetup as well. So a lot of familiar names, a lot of familiar faces that I'm seeing on the call. It's nice to see you all. If you've been to one of my talks before at chicago.net or anywhere else, you know I like to kind of make it interactive to get some feedback. That's a lot harder to do on a Zoom call. So maybe if I could ask if people have questions, maybe they could type them into the chat during. I'd love to address those questions while we're kind of on the topic, or if there's something going on, maybe one of the administrators or one of the organizers could watch that for me and just call my attention to any questions.
Yeah, I think we'll take a watch of that. And there is also a feature to raise your hand. I saw in here somewhere. Of course, now I can't find where that is right now. So.
Yes. Yeah, I think it's under the reactions button. I may not notice that just because I've got two screens up and all my presentation materials out, but if one of the organizers wants to give me the heads up, there's a clap.
I see.
Yeah, exactly.
That'll work.
Yes. If you wave a large flag in front of your camera or something, I'm sure we'll see. But yeah, maybe you can post your questions in there. So don't worry about interrupting with that. I'm happy to answer any of those questions. So today we're going to talk about a data access layer you're proud of without Entity Framework. And as John mentioned, his nopCommerce lightning talk was a pretty good intro there, especially when he was talking about the most recent version and how they've switched out Entity Framework for a micro ORM. We're going to talk more about that. I actually don't have link to DB, which is the micro ORM they use. I don't have that anywhere in this talk, but I'll try and remember to reference it a little bit since he brought that up earlier. All right, so I got to share my screen, right? Let me just find the right screen. Okay. Is everybody seeing the slide title?
Yeah.
Okay, cool. All right, so just a quick intro of myself for any of us that are joining a talk of mine for the first time. My name is Jonathan Tower. I go by Jay. That's what everybody who knows me calls me. A little bit more about me. I am a partner, founding partner and principal consultant at a company called Trailhead Technology Partners. We're a custom software development shop. We do all kinds of different business software, anything that needs to be custom developed, everything from web and mobile to IoT and backend and integrations. A lot of stuff in .NET, .NET Core. A lot of front end these days, obviously, in things like JavaScript. We do some Xamarin, we do some native mobile, and a handful of other things as well. I'm also Microsoft MVP, originally for ASP.NET, now under the Developer Technologies umbrella. And among other things, I also organize a conference in my hometown of Grand Rapids, Michigan, not too far from most of you, just around the bottom edge of the lake there, called Beer City Code. Maybe you're familiar with some of the beers that come from the West Michigan area. So we like to highlight our beer and our great software industry all together in that conference. Of course, canceled for this summer, but hopefully, you know, knock on wood, next summer we'll be able to do that again. If there's any questions you want to ask that you don't get a chance to do that tonight and you want to connect with me, all these places here are good places to do that. I'd be happy to follow up with anything. And also, I've got the slides up on my GitHub account, which is github.com/Jonathan Tower, and then it's DAL-without-EF. And I'll show that link again at the end if you're interested. And I can also share that with the organizers if they want to post it somewhere as well. All right, so a little bit about what we're going to cover tonight. I'm going to start with some of the pitfalls of Entity Framework. I imagine probably most of us, maybe all of us that are .NET developers in the audience tonight have used Entity Framework, at least some version of it. We've kind of got the two major versions right now. We've got the Entity Framework 6, which is kind of on the .NET side, and then we've got the Entity Framework Core, which is on the .NET Core side. I imagine most people have used at least one of those. So we're going to talk a little bit about some of the problems that you may have run into, some of the pitfalls of that. And then I want to talk a little bit about what do we actually even want from an ORM? What do we need it to do? What do we not need it to do necessarily? What's nice to have and what's kind of part of the core functionality of an ORM? Then we're going to look at something called a micro ORM, which John mentioned earlier, one of those in nopCommerce that the nopCommerce team chose to use. And they're really very popular these days. And a lot of .NET architectures I'm seeing are using micro ORMs. John also mentioned Dapper, which is one that I'll reference some tonight. And there's some other ones as well. And then I want to finish up by showing you an architectural pattern that's called CQS, which you can use this pattern that we're looking at tonight with micro ORMs to actually create a data access layer that's very powerful, safe, reusable, and helps you avoid some of those pitfalls that we're about to talk about with Entity Framework. If you've been to one of my talks before, you know that I like to do this at all my talks. My favorite charity is a charity called Charity Water. They help provide clean drinking water all around the world. And there's just shy of about 1 billion people right now that don't have access to that. It causes all kinds of other problems, including poverty and disease. And you know, I feel like even in the midst of this kind of weird world we live in, probably most of us are still gainfully employed. We are very lucky to be in an industry where it's pretty easy to find a job most of the time, and we get paid pretty well. So just to put my money where my mouth is, if you learn something interesting or fun or funny or anything that's useful to you at all, and you want to go to this bit.ly link, which is bit.ly/CNUG2020, that'll take you to a page where you can donate something of your choice. If you all collectively tonight give $100 while I'm talking, I will put my money where my mouth is and match that. So that'll be kind of a fun way to collaborate and sort of pay it forward together. And I always also like to say too, if you really hate everything and feel like this is a waste of your evening and you're mad at me, you can also give, because that'll potentially cost me $100. So that'll punish me. Okay, so let's start with the pitfalls of Entity Framework. So this is one of probably the biggest ones. I, as a consultant with Trailhead, have an opportunity to see a lot of different clients' software that they've already built. Sometimes we're enhancing it, sometimes we're fixing it, sometimes we're replacing it. And very frequently, performance issue that I see is a confusion between the iQueryable and iNumerable interfaces. Yeah, I'm just pulling up the, okay, so I'll have the chat up here, but it looks like you guys are just chatting. So I'll ask one of the organizers to let me know if there's a question in there, just so I don't have to keep stopping to read it. Kind of confusing thing about this is if you're familiar with these interfaces, they actually have almost exactly the same set of methods defined in them. You've got things like where, like select, like first or default. Some of the common things that you would actually want to use when you're using link are available both in iNumerable and in iQueryable objects, objects that implement both those interfaces. And it's very easy in your code to confuse the two. So if you look at this last line of code here I have on the slide, where I'm taking an object called my orders and doing first or default where the order ID is 170, you might look at this code and say, I assume what's happening there is that is an iQueryable. My orders is an iQueryable object, and that's building a query which eventually is going to get run as a select against the database, select star from orders where order ID equals 170. But that really depends on which of these option 1 or option 2 lines appears before it. Now, we all know, our methods could have hundreds of lines of code in them. Those lines, option 1 or option 2, could actually appear quite a bit ahead of this line. It'd be very easy to make a mistake and assume that this was iQueryable, when in fact, if it is this second option here, where it's been cast as a list, right here on this line, it's actually going to go to the database and pull back all of my orders from my whole database into this my orders object. And now they're in memory in my .NET application. Now I'm basically looping over all of those things in memory and looking for order ID 170 when I run this first or default. So pretty significant performance difference, both in what I pull over the wire from the database, how much memory I use for this query, and even the performance of finding order ID 170. You could imagine if your orders table had millions of records in it, this would bring your application down potentially, just with the sheer amount of network traffic and memory that this was using, doing it as iNumerable. So very powerful feature of link with entities, but also a very dangerous one because they look so similar. You can confuse those two. So I've made this chart to kind of show visually what that might look like. In the first situation, we're doing an iNumerable. So we've got our client application in .NET. If it's an iNumerable, we're actually going to go to the database, potentially pull back that whole table or that entire set of tables from the database, do the filtering in memory in our client code, and get our smaller set of data that we want to work with. In an iQueryable situation, we're actually building a query which does get executed finally when you realize it into some in-memory object. And what that might look like is you actually go build an iQueryable, which is very small footprint in memory and over the network. And then that's actually going to essentially send a SQL query over the connection to the database, filter in the database, which the database is really good at doing, send a very small package over the wire and back to your client. Obviously, that's the one you want to be typically doing, but with a link to entities, that can be pretty easy to make that mistake. Another thing I want to call out is just the performance. So Jon mentioned when nopCommerce changed over to use a micro RM, they saw pretty significant performance improvement with the application. It doesn't surprise me at all when I've helped clients move over to use a different data access layer than Entity Framework. That is often the case, or I should say pretty much always the case, that it's more performant. Now, in Entity Framework's defense, Entity Framework Core is actually way, way better, even than I think these statistics that I'm showing you on this slide. It's actually improved even more since I grabbed this data. The latest versions of it are even better performance. But that assumes that you're not falling for any of the pitfalls of Entity Framework and that you're using it the proper way. And sometimes, Entity Framework seems like an entire toolbox of tools. It doesn't seem like it's just one single tool that's meant to help you get data and update, insert data quickly. It seems like it's a whole set of tools with a bunch of other features related to data, change tracking, and a bunch of other things like that. And because of that, you do have that overhead that does slow it down, even if you are using it exactly correctly. I mentioned change tracking. That's actually one of the things that I see a lot with clients where they're having a pretty significant performance hit from it. A lot of times, .NET right now is being used to build APIs, REST APIs, maybe like a web API project, or in .NET Core, technically it's an MVC project with API endpoints. But if you're doing something like that, or you're doing an MVC application, or anything really web-based, you're doing application where your .NET code is running as a web application, you're really running in a disconnected environment. And what I mean by that is that the user might do a series of actions that calls, let's say, an API that goes and gets some data from your database and then serializes that probably as JSON over the wire and sends it to the front-end application. Then the application is going to do whatever it wants, and maybe sometime later a completely separate request will be made with an updated version of that object. And now you're basically reconnecting to the database and making a change. So change tracking is really fantastic if you're doing the opposite of that, if you're not in a disconnected environment. So imagine like a desktop application, for example, or maybe you're doing a large bulk update and you want to be able to loop over a bunch of different objects that you might want to update, and you want to just track the ones that actually need to be changed over a large amount of potential changes. Those are things that change tracking does really well. If you're about to serialize that data and send it over the wire, you're now in a completely disconnected environment from that data. You have no idea if or when that's ever going to come back. And when it does, obviously, it's a brand new request and response cycle. It's a brand new context at that point. So now any change tracking that you might have had on the previous request is totally moot. So what I often tell clients is, all you have to do in Entity Framework is, and you can configure this globally as well, but if you have any query, you can just do as no tracking, like this line right here in red, and that will turn off change tracking for that query. So you want to do that obviously before you implement the query, that as no tracking is only available on the iQueryable interface. Once I cast this as a list here, it's IEnumerable now. Now I won't have that as change tracking available to me anymore. It's too late to do that without change tracking. But right here before the to list, I can do that. And that'll just basically tell Entity Framework, go ahead and do this query, pull the objects back into memory in the DB context for me, but don't track changes. There's quite a bit of overhead that comes with that change tracking, both when you do queries and the objects are first pulled into memory, and then obviously as you make any changes or loop over those objects, change any of its properties, that change tracking is going to definitely add overhead. And if all you're doing is about to serialize that to JSON, it does not make a lot of sense to have that change tracking on and take that performance hit. So keep that in mind. All right, now the one that it's not maybe as common as the IEnumerable versus iQueryable thing, but it is one that I see causing the most severe performance problems in applications with Entity Framework. And that is people who unintentionally are doing lazy loading. So imagine a scenario like I've got here on this slide where I've got orders and order details in a database, and I've created a DB context for Entity Framework with both of those represented as different entity sets. I could easily do this first query here that I'm going to get the orders where the status is some status ID of 1, and then cast those all to a list. So now they're in memory in my application. Maybe those are my unprocessed orders, and this is the code that's waking up on a schedule to process them or something like that. So that would be a totally acceptable thing, perhaps, if it wakes up often enough. That would be an acceptable thing to do to list like this and pull that into memory. But now, if I have an order details object, if I have an order details navigation property on my order objects, that is set to lazy load, meaning that when it's accessed, it will actually go back to the database and execute a query to pull back the objects on demand into that property. If I do this next line of code, which has the if orders.any on it, where I'm looking to see if there's any of these orders that have an order detail count that's equal to 0. Let's say, for example, that if I'm processing these orders that need to be processed with a status of 1, and there's any that don't have order details, those are junk and I just want to ignore them, or maybe I want to delete them or something. What I may not realize is that if I just pulled back 100 orders, I'm about to go issue 100 queries to my database as I do that orders.any. Now, it does depend a little bit how this works, depending on which version of Entity Framework you're on. And I will say that in Entity Framework Core, lazy loading has been turned off by default. So in EF6 and before, any navigation property like this by default is going to have lazy loading turned on, which means it's going to issue those queries without even really looking at it. I mean, if you look at this code, it seems fairly innocuous. I look at it and say like, oh, it must already have gotten the order details. I have to actually look at the query up here to see that there is no .include order details. It's not actually pulling those back as part of the original query. So here it's actually going to be loading them for each and every order in this collection. Now, obviously that is going to not perform very well, especially if I have thousands or even more order objects in here. So here again, similar to what I was talking about with iQueryable versus iEnumerable, very powerful flexibility in Entity Framework that can get you into some trouble if you aren't really careful. And somebody did point out that I'm missing the closing parenthesis, so I appreciate that. Here, I'll do, since you guys are friends, I'll do a live fix on that. Oop. That way.
This is really what our attendees come for, is to see some live coding, so speakers
Yes.
crash and burn.
Uh-huh.
I'm saying as a speaker myself, so. Right.
Yes, it's always enjoyable to point out to the speaker that they screwed something up, right? It might surprise you guys, but I actually don't have a compiler to help me out in PowerPoint with some of these, so. All right, we got that line fixed. So thanks for pointing that out, Sean. Okay, so we talked a little bit about some of the pitfalls. Maybe some of you have run into that as you've been using Entity Framework in some of your projects. Maybe you've seen some of the performance issues that come out of that. So let's kind of back up a little bit and say, what is it we even want our ORM to do? Because maybe some of these problems from Entity Framework are because the ORM is trying to do things that we don't even really necessarily need it to do. I mentioned change tracking, for example. So let's look at some of these. Now, this is a list, a personal list for me, but this comes from my, honed over my 21-year career in software development right now. I really like my libraries to do one very narrow thing and to do it very well. John in his talk also mentioned AutoMapper. Absolutely love AutoMapper. If you have one object and you want to get it into another object, often it's for mapping like models to DTO, data transfer objects. AutoMapper is the absolute best way to do that. You could also write the line of code where you say, set the first name property to the first name property, set the last name property to the last name property, right? And run through all of those. Chances that you're going to miss something or make a mistake or change one of the properties later and not know that something is wrong, pretty high. AutoMapper, it does one thing, it maps one object to another, and it does it really well. I feel the same way about my ORMs. I want them to basically help me query a database or some sort of data store and map that, let's be honest, probably tabular data of some kind into objects, because I write most of my code in C#, and C# is an object-oriented language. If anyone's ever used the data tables or data readers before in ADO.NET, you know that working with tabular data is a real pain in the butt. In an object-oriented language, it's nice to map that tabular data from your data store into something object-oriented, especially when you're talking about things that have complex relationships, like the order with the order, child order details collection, and so on. It's nice to not have to worry about all of that, but have it just loaded for you. So that's the first thing I'm looking for. The other thing I'm looking for is going just the other way. If I'm doing an insert or an update, I want to have it map the other way. So I want the object to automatically write the SQL statement for me. I get pretty bored all day if I'm just writing SQL update and insert statements and putting all the parameters in line for all the different properties for those all the time. It would be really nice if I didn't have to do that very basic wire up code all the time myself. So that's the first thing I'm looking for my ORM to do. The second one is sometimes I like to think about it this way. I like to have more direct control over the SQL syntax that's generated by my ORM. If anybody's ever worked on a larger project or in a company where there's a database developer, database administrator who cares about this sort of thing, or maybe you've had SQL queries that have not performed well and needed to be tuned in your application, well, you know that when you write a query like the one that I'm showing right here, which is very powerful link query syntax that we can do in C#, but we all know, I think, unless anyone in the room is a link to entities expert, I think if we look at this with the subquery going on here with the first or default, I don't think any of us is exactly sure what the SQL might look like that this generates. And I can tell you that it actually depends on what your data store is. It also depends on what version of entity framework you're using, what the SQL is going to look like that this generates. But I will also tell you that no matter what version you're using, it's not the SQL that you would have written if you were doing it yourself. It is quite a bit more complicated than that. It tends to perform pretty decent most of the time, but the more complicated nested type scenarios you get like this, the more likely it is to not take into account some of the, let's say, indexes that you have in your database or other things like that that are going to help it perform well. Now, let's imagine we had this line of code in our project and we knew that a fancy, expensive consultant was coming along that was going to be looking at query performance tuning. I don't know about you guys, I would feel a little self-conscious about this line of code and maybe any queries that were more complicated than this, wondering what they were going to say about the SQL that this generates and how performant it is. I'd be even more nervous if they came back to me and said, hey, I was looking at your office addresses query and I want to suggest that you change the SQL to look like this. It can be done. I have done it before for projects, but it is very difficult to start with the SQL and then write a very complex link to entities query and to get it to generate the SQL exactly like that. So if you want a performance tune, it would be nice if your ORM could basically be told what SQL to run. What if you could do something like this, where you basically defined a SQL statement from, let's not get into the weeds too much on where it comes from, but let's just say in the simplest scenario, you just define it as a string like this. Say I want to go select these fields from the orders table where these certain conditions are true. And then what if you could basically tell your ORM that you wanted to run that SQL and map it into a list of a certain object type that you have defined ahead of time? That would be pretty nice, right? The other thing that I look for in my ORMs is to kind of get away from that pitfall that we started with, the iQueryable versus IEnumerable. I like to, at a glance, anywhere in the code, be able to tell if a line of code is executing against the database or if it's executing something in memory in my application. Now, if we use that earlier example, if I go back a slide here and say we were using a micro ORM that did something like this, that basically ran a SQL string and mapped it into a list of objects for us. If we were doing that, I could look at these first 2 lines of code here and say that for sure is running some SQL, and I don't have to worry about whether that where is going to happen in memory or if it's going to happen off in the database. I know for sure it's going to happen in the database. I can also look at this link where on the 3rd line of code and see that the is complete equals true filter is going to actually be happening in memory, because if I'm doing an ORM like this, that's the only place for a .where to do its work. There is no iQueryable in this case, just IEnumerable. So now anytime I see link syntax like that, I know it's doing in-memory logic. The other thing I like out of a data access component is code reuse, basically. So if I have a query that is only used in one place, that's not uncommon, but I might also want to have a query like query B in this diagram that I can reuse in a couple different places. Maybe it's, you know, for a given username, I want to get the user ID because certain parts of my application need to know the user ID. Maybe I want to reuse that query. I don't want to have to rewrite it over and over and over again. If there's a bug in it, I don't want to have to worry about finding all the places to update it. I want it to be in one place. That's just reused. So I want a data access layer that has components like this that are reusable throughout. And then maybe some niceties. Now we're getting kind of on the bubble where I would say these things are niceties that I sometimes like ORMs to do, but it's not critical. So for example, automatically filtering my queries, maybe by user ID, or maybe I have a multi-tenant database and one tenant should never see another tenant's data, but they might be stored together in the same database. Maybe I want the multi-tenant filters to get applied automatically. Maybe I want my audit fields to get set automatically, like my last updated user and my last updated date. Maybe anytime I do an update, I want that to automatically happen, so I don't have to remember to write that over and over. Those are some niceties that I might want an ORM to do for me as well. All right, so we're about halfway through, so this is a good time to just remind everyone about this bit.ly link here, and I'm actually going to go to it right now and see how we're doing. There we go. Okay, and it looks like we've already hit $100. So you guys have cost me $100 tonight, but it's for a good cause, so I appreciate it. If anyone wants to give, obviously you're still welcome to do that the rest of the talk. But thanks everybody who has given. Okay, so let's move on to this next section, which is about micro ORMs. Jon, in our lightning talk at the beginning, talked about one micro ORM, which he mentioned he hadn't heard of it before. I've only heard of it before. I've actually never used it before, so it's a little bit new to me as well. But let's look at a few other ones. But first of all, what makes an ORM a micro ORM? Well, obviously micro implies small. What does that mean exactly? Well, it's up, small is in the eye of the beholder, I suppose. But what I would expect a micro ORM to be is two things. First of all, I would expect it to be an ORM, which means it maps objects to queries and queries back to objects. And I would expect it to be micro, or I would expect it to be small and lightweight. So I mentioned in my career, I've sort of gravitated over the years towards libraries that I can rely on that do one thing and do it really well. Log4net for logging, or Dapper for micro ORMs, or AutoMapper for mapping between objects, REST Sharp for making calls to REST APIs from C# code, things like that, that just basically do one thing and do it really well. Some of the things you're unlikely to find in a micro ORM is things like lazy loading. We talked about navigation properties and entity framework. Very unlikely to find that in a micro ORM. It's not impossible, but it is unlikely. Query caching, entity framework actually does this. A lot of people don't even know about it, but when you run the same query multiple times, it will actually cache the query plan, so it can use that to be a little faster the next time. Identity tracking, if you run a couple different queries that pull the same order object into memory within the same context, the second one may actually just reuse the existing one that you already have, depending on some other characteristics of how you're doing it. Change tracking we talked about, basically dirty flags on fields, which objects have changed, which ones need to be inserted, which ones need to be updated or deleted. Object-oriented query languages like LINQ, some of the LINQ queries we've been looking at, language integrated query, if you forgot what that stands for. That's a feature you're fairly unlikely to see, although it looks like link to DB that Jon mentioned earlier that nopCommerce shows does allow you to do some of that, so that's kind of interesting. And then another thing that's not usually built into an ORM is the concept of a unit of work or a transaction. Often they will inherit that from whatever the data access layer that it's using is, whether that's SQL Server or something else. So let's look at a few examples so you can kind of get a feel for what a micro ORM might look like. This is from a code sample from a micro ORM called OrmLite. It's part of ServiceStack, which is a paid framework that you can get. It has kind of its own way of doing things. It's just a little different than the other ones, but conceptually similar. So they have this connection factory. I'm using an in-memory database. Obviously, if you had a different connection here, like to a SQL database, you would use a different provider over here, like the SQL client. But then you tell the database factory you want to open a connection, and it creates an IDB connection. That's the same IDB connection interface that you're familiar with from your SQL connections or other database connections for years and years in .NET. And then they've got some extension methods that they've added to the IDB connection interface, like drop and create table, where you can say, create me a table for to-dos and drop it if it already exists. Obviously, that one's a little dangerous. If you're running against your production environment, you might want to make sure you're only doing that in your local development environment. You can also do things like creating an object with properties and then telling it to save that to the connection. And finally, you can also look up by ID, where you pass in an ID and tell it what object type to map that to, and then update some field and save, and it will do change tracking for you. You can also delete by ID. PetaPoco is another fairly popular micro ORM that I've seen used quite a bit. It does things similar, but a little differently, a little different syntax. So first of all, it uses this PetaPoco database object to create the IDB connection. And here's where you pass in your connection string. Unlike the previous one or the next ones we're going to look at, when you tell PetaPoco that you want to save, or when you tell it you want to delete something, you have to tell it both the name of the table and the ID column to use, and then pass the actual object that has the property values that you want to use. So you can also see here that it's got a query syntax where you can pass in a SQL query and tell it to map the results of that to a certain object type. The delete works a lot like the save, where I tell it my object table name and tell it the ID column to use. Now Dapper, I'll just give you guys a heads up. This is the one that I prefer. This is the one that in all of my applications that use micro ORM for their data access layer, this is the one that is my preference. There's no particular reason for that other than I just really like the way it works and I'm familiar with it, and the syntax is the one that I like the best of all of the ones I've looked at. But you can be the judge of that yourself. They all function fairly similarly, so whichever one you are attracted to is probably not going to be a huge difference. So here I'm doing an iQuery, I'm doing a new SQL connection object, and then there's a new query method with a generic subtype on it. That is an extension method, just like we saw earlier on some of the other libraries, added to the IDB connection interface. So if you actually look at the code for Dapper, it's largely implemented as extension methods to the IDB connection interface. Most of the code is actually just extension methods. There's some helper stuff under the covers, but the stuff that you actually interface with directly as a consumer of the library is mostly that IDB connection extensions. So here I'm running a query. Looks pretty similar to the last one we looked at. And it's actually going to come back as an IEnumerable. If I want it to be an IList instead, I can cast it as a list. That'll be a list of to-do now. Oops. I can also execute parameterized SQL. I really like this syntax from Dapper. So if I have a command like this update statement where I'm updating all my to-dos to set completed to some value, where the ID is some value, I can then pass in those parameters as a dynamic untyped object like this, and it's going to match it up by type and property name automatically to my parameters in my SQL query. And if you're wondering, does this do all the stuff you would expect SQL parameters to do, like preventing SQL injection and stuff like that? The answer is yes. It's kind of the point actually of these parameters, is to make sure that your code is not basically building up SQL strings and potentially susceptible to SQL injection attacks. Some of you may already know this. Maybe we're thinking about this earlier when I was knocking pretty hard on Entity Framework, but you can actually kind of use Entity Framework as a micro RM. There's this one method particularly called from SQL that's available on your DB sets in Entity Framework. I say kind of micro RM because once you do this, Entity Framework is going to do all of the other things that it normally does. It's going to do change tracking. It's going to do navigation properties if you have those turned on, and so on. But let's say you're all in on Entity Framework already. You don't have time or the availability to rewrite an application and get Entity Framework out of it, but you want to still be able to take that query that high price consultant came in and told you use this instead. When you're querying blogs, you should use the stored procedure I created for you. That is going to perform a lot better than the SQL query you're running right now. You can do that with this from SQL method. So just some quick examples of it. It does hang off the DB set, so you do still need to have your context dot and then your entity DB set of whatever type you're trying to load. And then you can say from SQL and then provide basically any SQL statement you want there. Here's a select statement. Here's an example just below that with a execute of a stored procedure. And then you can even see here with SQL parameters, I can do a parameterized query as well, in this case, against a stored procedure. So that does give you that performance boost of querying exactly the way you want to query your blog objects or whatever objects you're going for out of your database. All right, so for the last section, I want to talk about kind of bringing this all together. And to do that, I want to talk about something called the CQS pattern. You may have also heard of it as CQRS. I'm going to talk a little bit about the difference between those as I see them, even though there really is no hard and fast definition of either of them. Okay, so let's start out with CQS. It's a simpler one. When people talk about CQS, they're talking about command query separation. And basically what it means is it's an architecture where you create command objects and query objects. Command objects are meant to update, insert, and delete data. And query objects are meant to get data, query data, as it were. And never the two shall meet. So those two never cross. Typically in this pattern, your command objects wouldn't return anything. They'd return void. And they would only mutate object data in your data store. Typically, queries would only return results and be immutable. In other words, if the database hasn't changed at all, you could run that same exact query a second time and get the exact same set of results. And typically wouldn't do anything to update your object state. In other words, wouldn't change anything in the database at all. what that might look like, imagine this yellow box here is your application. It could be the UI layer, it could be your API layer, it could be your middle tier, whatever. This is your application logic here in the yellow box. If it wants to read, it's going to create a new query object, which is basically only going to read. It's not going to ever write to the database. It's only going to read from the database and return you an object or a list of objects or something like that to use in the application's business logic. If you want to write to the database, you always will create a new command object of the type that you want, and it will write to the database and typically not give you anything back, although I do think that that's the one area where I see the most value in making an exception, which is that I like my insert statements to insert, update, and delete at the very least to return a Boolean to indicate whether they were successful or not. Sometimes for inserts, it can be very helpful for it to actually return an ID so that you can tell what the new ID of your newly inserted record is in case the next step in your business logic is to take that ID and do something else with it. So that's kind of that one exception to the commands not returning anything that I think is pretty reasonable. There's also an exception to the queries not writing anything, but there's some other ways to solve that. But that exception is if you have an audit table. So if you have a table that basically audits reads of certain records, you're obviously writing to that audit table anytime a query against that table happens. Now, it depends totally on how you want that to work technically. A lot of times those audit tables will be done in the database layer, and in your data access layer, you don't have to worry about it at all. If your data access layer is doing that, I would urge you to actually wrap that so that the query maybe calls the command. So you're still not doing any updates from the query, but the query and the command are tied together maybe in some other business logic object that does both the query and the audit update together. So let's look at some samples. Now this is total pseudocode, so hopefully you don't find any syntax errors in here. But imagine that we wanted to implement something like this. So we're going to go query our orders object by creating a order queries object. And because we're good .NET developers and we're going to use dependency injection, we're going to create an interface for that as well called iOrderQueries, so we can inject our order queries throughout the application. And now I'm going to create a method that's called getOrdersAsync. And all this is going to do is just go get me all of my orders from the database. Maybe I have another method in here as well that's called like get active orders or get my orders or something like that. All of which would obviously have different wheres. Maybe they would have different columns depending on how they were being used in the application. But I can totally build that to purpose depending on how I want this query to work. And then, like we saw, if we're using Dapper, I would just create a new connection of the type I want and open that up to the connection string specified. And then I would await the query async method and say, go do this query now and map the results to an order DTO object. Now I could have different order DTOs. Maybe I could have a full order object. I could have an order DTO that's maybe a little more stripped down for just some pages. And maybe I have a like OrmLite that even has fewer columns on it. Maybe I have like one that has order ID only if that's all I'm trying to get. I can really kind of go crazy here and create as many different methods, as many different DTO objects or model objects as I want to create for the exact purpose that I need them for in my application. Okay, so that's what a query object might look like. I could have lots of methods in there, so I can do lots of different queries against my orders. A command object could look the same. Maybe I want to be able to update my orders, and the way that might look is like this, where I create an order commands class, and I'm going to give that an interface as well, so I can dependency inject it. And then I'll have this update order async, which takes my order DTO as a parameter. Again, we'll just create that SQL connection object and open it. And then now Dapper, if we're using Dapper, has a execute async command where I can execute a SQL query, SQL command, I should say, like an update statement. And I can parameterize that as I showed you guys earlier, where I can set whichever fields I want to set from this particular object. I can obviously filter it by the order ID, so I'm only updating that one. And then I would also say, here I might throw an exception, let's say, if the order rows affected on this update are not 1, if it's not exactly 1, I could throw an exception. Or as I mentioned earlier, this might be a good place to actually, instead of just returning a task from this method, I could return a task of Boolean or a task of integer or something like that. So I could actually return a Boolean to indicate that it was successful, or maybe an integer to indicate the number of rows affected, or maybe an integer to to return the ID of the row that was updated. Kind of depends on your preference there. But you could also throw an exception. I probably wouldn't recommend that actually though, because a lot of us know that good architecture involves not using exceptions to control the flow of your application, and that's kind of what this sample code is doing here. All right, so how would you bring that all together? Well, because we were using good dependency injection on all of those classes, there's supposed to be a D right here. So I've got my order commands interface and my order queries interface, and I'm injecting them here into like a MVC or web API controller in my application. And I've got a couple different methods here, like a put that does an update. And all I need to do is just tell my commands to do an update. And same thing with orders. When somebody wants to get all the orders, I just run the query and return the results of that inside of an OK 200 response. If I have something more complicated to do, like maybe I have one endpoint that updates a database, updates a order in the database, and then returns something as well, you could see how you could start to put those together into things that are happening, larger things that are happening in your application. Okay, so now let's talk about this. To me is maybe the most confusing part of this, so try and stick with me on this, and just know that if you don't totally follow this part, it's not the most important part of the talk. But CQS is what we were just talking about. CQRS includes everything that I just talked about in CQS and adds another bunch of other things. And if you go Google this, you'll find basically every blog post you find about CQS or CQRS will have its own opinion about the definition of each of those things. So I'm going mostly off of what I've seen over the years historically these terms used for, trying to kind of clarify it. So CQRS is actually older, and it stands for Command Query Responsibility Segregation. It's actually part of the domain-driven design architecture, if you're familiar with that at all. DDD, it's called sometimes. It can involve things that are a little more complicated, like using queues and events to trigger updates instead of doing them synchronously. It often involves using completely different models for your queries than you use for your updates. So you noticed in my example code, I used that order DTO on both the command and the query. In pure CQRS, you would actually have to have two different ones. So you'd have like an update order DTO and a query order DTO or something like that, and never crisscross those or share those between the two, because the commands shouldn't know anything about the queries and the queries shouldn't know anything about the commands. And then the other thing that the CQRS architecture often includes is actually writing to one copy of the database and reading from another copy of the database. So sometimes you'll write asynchronously through a queue. It'll update one copy of your database and synchronize over to your read copy of your database. It's a way that you can actually create a more performant application, even on like a relational database, by having two different replicated copies of your database and having one of them be your read and one of them be your write. But basically know this, CQRS is a lot more opinionated, has a lot more aspects to it than CQS does. At its core, CQS is just about creating command and query objects to access your data. All right, so these were the things we were going to talk about, and we talked about all of those now. We also checked up on the charity water, which I see has gone well over $100 now. So thanks everybody for your generosity. That really does mean a lot to me. I appreciate that. And now we're at the part where you guys get to ask some questions. So Dave and Mayak, have there been any questions that I've missed so far?
I don't think so. I think there's been a little bit of discussion. Actually, here's
Okay.
a question that just came in here from
Yeah.
Rodrigo. So I don't know if you want to read it and maybe, like I say, for the recording, and then give an answer to it. So
Yeah. So the question that I'm seeing is, would you recommend to use Entity Framework instead of an ORMF? Is that, I'm not sure what we mean exactly by ORMF, but oh, it's just a typo. So the question is, would I recommend using Entity Framework rather than a micro ORM? Rodrigo?
You can unmute yourself if you need to.
Okay. Yeah, Rodrigo says that's correct. Okay, so you know, there's nothing wrong with Entity Framework. I mentioned earlier that it's very powerful. To me, I think of Entity Framework as an entire toolbox full of tools. It does all kinds of stuff for you. I bet you most of us have only scratched the surface of Entity Framework. The number of features that are available in there is immense. Sometimes you want to bring your whole toolbox to go do a project, and sometimes you just want your screwdriver, you know, or your power screwdriver or whatever, and that does the job. For me, maybe I'm a control freak. Maybe I've seen enough projects that went wrong where the architecture, the developer didn't have maybe enough knowledge about Entity Framework, and it kind of went off the rails and performance got pretty iffy. Maybe I've seen enough of those that is what bumps me in the direction of an Entity Framework, or I'm sorry, of a micro ORM rather than an Entity Framework, just because it gives you so much more control. But we also saw some examples in Entity Framework, like the from SQL method, where you can actually take some more of that control. So I guess the short answer is sometimes one is good and sometimes the other is good. If I have the preference, nowadays I usually start with a micro ORM instead of Entity Framework. You know, I'll add one more thing to that answer, which is that there's a few things Entity Framework does that micro ORMs can't do. And if you have to be able to do those things, you really need to use something like Entity Framework. And one of them is, we saw some of the examples earlier in Jon's lightning talk of the repository pattern. If you're familiar with the repository pattern, it's a way of kind of wrapping, especially if it's wrapping Entity Framework, it's a way of wrapping the complexity of building the base queries, but then it actually can return an iQueryable, meaning that the calling code can actually make changes to that query before it's actually been executed. If you have a business application that has to be able to do that, where there's like a library that has some base queries in it, but those queries have to be altered, and those altered queries have to run as pure SQL, probably the easiest way to do that is linked to entities and passing iQuerybles.
So Jay, an example of that is if you were developing a GraphQL API or something like OData, where you're kind of letting the user pass in these various query parameters.
That's right.
Can you write code that will basically build up that query yourself and then pass that on to your data store? You can.
Right.
That code is extremely challenging to write.
Yeah, exactly. Are you going to write it better than the Entity Framework team? Probably not, right?
Right. Yeah, those guys are pretty smart. Guys and gals on that team are pretty smart. That's a place where they're really going to shine, and you probably don't want to attempt that code yourself. So yeah.
Yes, exactly. Very good point. Thanks, Dave. Question: how about intersection of a business logic layer and the unit of work pattern? Any good examples out there that you might recommend? So if you've ever done any work with the transaction scope object in .NET, that's a pretty good way to handle unit of work. You can wrap it inside of your own object that you make like a unit of work object in your own data access layer, or you can just use it directly in your code that's calling your data access layer. But in that example I talked about where you could have an endpoint in your controller that did both an update and a query. Maybe it was doing 2 updates in a query. You wanted those updates to only happen if both updates were successful. You would obviously want to wrap that in a transaction. And in .NET, the best way to do that is something called the transaction scope object. You can actually run 2 totally separate connections as long as the, commands, as long as the connection string is the same. That transaction scope will scope them together, even if they're happening in totally different object hierarchies from each other. So that's a really good way to implement that unit of work pattern for the CQS or CQRS patterns. Does that answer your question, Paul? Paul says yes. Okay, perfect. The next question I'm seeing is using an API which can expose both EF Core and Dapper. How can we send queries or write link in the UI and send that over to the API? This is a new API data layer we're proof of concepting. Yeah, so actually this gets back to Dave's point just a minute ago. If you're trying to write something that's extremely flexible, so if you're writing your own library that's meant to be the data access layer for everything in the future that you can't even imagine now of your applications, if you're trying to be that flexible and you want to be able to return queries to be queried by calling code, you might want to actually stick with something that is link-based. So linked entities is the obvious choice there for .NET developers. John earlier mentioned link to DB. Maybe that would be an option for you to look into as well. Another thing to think about here is if that API is a REST API, there's something called OData that you can essentially put on top of REST APIs. It's a .NET library basically that allows you to essentially query underlying data stores through HTTP. So if you think of the way link lets you do that in your C# code, it lets you say, hey, I'm trying to access this DB context.orders, but as you kind of build a query up there, it's building up a query object, and then when you finally execute it, that query object actually gets executed as SQL. If you kind of move that up one layer to the HTTP stack, OData works the same way. It allows you to build an HTTP query that says, get me these columns from these tables, joined in these ways, with these where clauses on them, and to basically have the code underneath that just interpret that at runtime and build the correct logical SQL statement to do that. I will give you a couple of warnings about that. Usually what I see is that if it's not absolutely necessary for a REST API to be super flexible, it's better to make it purpose-built. In other words, if you try and create a REST API that solves every future problem that you might have, you're probably going to end up with a pretty mediocre REST API that doesn't do anything super well. So that's my sort of caveat about that answer is, if it fits your architecture, it might be better still to build a purpose-built REST API that just returns exactly the columns that the user wants for different queries, does the exact wheres that you need, filters you need to do in certain places, and doesn't leave that up to the front-end application to properly pick those things. What I usually see happen in those situations is the same pitfalls that we talked about with Entity Framework, and performance problems start to get introduced with OData. Okay.
Yeah, just to follow up, Jay, I mean, the great strength of those applications is they let you query on anything that you want. But the great weakness of those is they let you query on anything you want. And so now you're doing a full table scan against a table that has,
That's right,
150 million records, which leads to great sadness on the part of your DBAs and others in your organization.
Exactly right, yeah.
So, yeah. And we try to avoid the great sadness here in Chicago.
Yes. Yes, another, well said, Dave. So that is basically the same problems that we talked about at the Entity Framework layer, but just now pushed up a layer, is kind of how I think of it. So someone says, I'm sort of thinking in terms of an architecture like CSLA. However, CSLA seems rather heavy for many applications and perhaps more complex than most developers care to tackle. Any thoughts on code generating aspects of the DAL with these concepts? So there's a little bit more after that, but let me address that. If you're familiar with T4, T4 is the template code generation language in .NET. So basically you can write code that generates code. A lot of Entity Framework over the years has actually used T4 templates to generate Entity Framework model objects. So if you've ever done like reverse engineered a database into models, you probably, whether you know it or not, you probably use the T4 template to do that. There are some libraries out there that the whole reason for their existence is to connect to a database and reverse engineer it. There's one I used to use a lot. I haven't used it in years now, but it was like, what is it called? ReversePoco or something like that. ReversePoco generator. I don't know if anybody is still yet. It still looks like it exists. So if you're using something like Dapper, but you don't want to, copy and paste all the column names and turn them into the right types for properties in your C# code and so on, that ReversePoco generator, if you search for that, it's called ReversePoco generator. It's like a plugin for Visual Studio. And yep, there's the link for it. Thanks, Paul. That is, that's an option. There's also T4 templates, and there's a number of other libraries I've seen over the years that have been built specifically for that purpose. Just reverse engineering database tables into C# code. And then let me see if there's another question in the second half here. So writing some of the bare SQL, particularly when dealing with primary keys, combined with parameters would seem potentially error prone. One of the things I like about Entity Framework's Fluent syntax is that it works with IntelliSense and has compile time checking. Yes, that is true. You do lose that a little bit. There's some ways that you can architect your query. So a lot of the examples I was showing were obviously oversimplified and using just SQL defined in a single string. A lot of times those are actually going to be built using some sort of logic in your code. And that particular code could actually be a little bit smarter. You can also, obviously, if you're reverse engineering your database tables into your models, you can catch errors there because all of the parameterization is going to be strongly typed. And the parameterization of your queries and commands will actually catch if like a column name changes or something like that. The other thing that I will just point out about that is, all of us, I think, like to try and keep things flexible, and I think that's good. How many of us have written an application where we wrote a data access layer where the database could be completely swapped out? It started as SQL Server, but we wanted it to be able to also work if it was SQLite or Oracle or a bunch of other things. And we've completely abstracted it away. And then how many times after writing that has that change ever happened? For me, in 21 years, almost never. Often once you kind of pick a stack, it ends up staying that way. I think you could apply that the same here to your SQL statements. Do they change? Yes, they do, especially during development. Once the application is launched, there's a lot of reasons why the database schema doesn't change quite as much anymore. The risk goes down quite a bit for that. So hopefully that answers your questions, Paul. Good questions. Okay, then Rick says, the reason we moved to API is because we have older UIs.NET and want to build new systems in core. So I assume we're talking about a REST API, like a web API type of project there. And that's a really great modern architecture to build APIs like that. If you think about the front ends that you're likely to build, it could be a desktop application, it could be IoT, it could be mobile, and it could be web. Those are kind of the big ones. All of those work really well calling APIs. So if you write most of your business logic in APIs, and then you just think about the front end as being sort of the presentation layer, and it could be multiple front ends. That's a really great way to do it. So does that answer your question, Rick, or address your comment? Okay, cool.
I was just going to say, Rick, I mean, if you want to kind of stick around afterwards and kind of chat some more about that in detail, I'd be willing to stick around and chat. You know, we got one of the advantages of coming to user groups is, you know, we got a lot of experienced people that come to these. We got people of all, you know, done all different things that, like I say, you know, maybe somebody's encountered something that helps you, right? And you know, they've crossed that hurdle before, and that's really what we're here for. So,
for sure. And even though it's virtual, we can still help each other the same, right?
Yeah.
I think that is, oh wait, is there a new question here? Oh, Paul's got a tip. If you want to mix a bit of entity framework with your own SQL, it's possible to get the DB connection with entity framework like this. So DB context.database.connection string, or in core DB context.database.get DB connection. Yep. Thanks for pointing that out, Paul. Obviously, in a lot of my examples, I sort of oversimplify that stuff, but that's good to point out. So I think that's the end of the questions at the moment. And I think we're getting fairly close on the time. Do we want to take any more time for questions, or do we need to move on? I'm happy to answer more questions if there are any and we have time. Okay.
So we can quickly do the raffle, and I'm going to stop the recording here.
Okay, sounds good.